action. This is an example of a design, and it's, you know, a layout, and it shows things like, you know, existing vegetation that was there on the site. It shows the infrastructure, the buildings, the patios, the access pathways, and then it shows all of the plants and waterworks and things, water holding tank, different trees, different shrubs, vegetables, things like that, how they're integrated together. And so this is kind of one, you know, representation of a design, but you don't necessarily have to do beautiful artistic drawings like this to work on permaculture. I mean, the best designs, I still think, like the designs for our urban lot that I was showing you before, and the designs for my family's farm where we put in those big swales and those native plants and fruit trees, they were never, I don't have any designs like this. They were all trial and error and just, you know, going, you know, had a design drawn out on a piece of paper like this, and, you know, we worked through many copies and lost many copies of the design and redrew the design and, you know, learned as we went. But there are kind of some big questions to think about in design. Permaculture emphasizes patterning and following the natural patterns. That's why one of the big principles is designing from patterns to the details. So looking at the big picture first, making sure you're observing the patterns that are going on your site before you come up with new patterns or things that you're going to add on to that pattern, because that's the way to really save as much energy as possible, is to work with and harmonize. Like when people ask me, you know, you think about permaculture and there's lots of long, complicated definitions, but if somebody asks me, you know, just comes up to me and says, what is permaculture? I say it's harmonizing ourselves with patterns in nature. That's as simple as I can make it, and that has kind of two sides to it. It's observing and understanding patterns in nature and figuring out what we can do to harmonize with it. So those are like kind of, in a simplest form, what I think the permaculture design process is. So
Can you give an example of that? I don't feel like I understand that.
That means that you have to put energy into first making observations on the site, spending time on the site, looking through what the characteristics of the site are first to be able to tell what kind of patterns are going on.
Give me an example of what a characteristic on the site would be, like a slope,
Okay,
or
yeah.
what are we talking about?
So those things include the climate.
Climate? Okay.
Yeah, the slope. So I'm going to give some examples of these. We're kind of getting there, but
Okay.
the soil type, the existing vegetation,
Okay.
the access,
Okay.
all of these things are in some kind of a pattern. Everything natural in nature occurs in patterns, and it's because of the relationships that are going on there. And then you have to find out how, by observing those patterns, what's happening on how energy is entering a site, how nutrients are cycling during different times of the year, between different plants. How can I, you know, make small changes to benefit more from those processes that are already happening? So a couple of the main questions that you're going to be asking is, okay, I want to achieve this function. I want to have fruit, so I want to plant a fruit tree. Well, where should that go? So how do I place that? Where do I place that in my system? And with what other things to make it benefit us the most? So I'm going to, a couple of examples here. A big one when you're starting out in the biggest picture, thinking about what are the patterns going on here. In a cold climate like this, you definitely want to think about climate. Think about temperature and precipitation. What times of the year. So this is the hardiness zone map, the USDA hardiness zone. There was a picture of the whole U.S., but this is more specific to Illinois. And what the hardiness zones are is they measure the extreme temperature average. It's still an average, but it's the extreme average, so it tells you what the coldest it gets normally is in every year. And that's what, for a large extent, determines what will survive in your area. So you'll see that, where are we right now? We're right about here. Somewhere in that area. Kane County, so we're somewhere right about in the middle of Kane County. So we're looking at, we're like 5A or 5B zone. So then you can use this and you can, right away, you can say, okay, I'm looking at what types of fruit trees or what types of, any types of trees will survive in my area for perennials. And so you can do a search and you can just look and narrow your search down to those types of trees to know what will be appropriate. Another big thing, getting from climate, this is a soil map of this site. And this comes, we have a lot of resources that we can use when we start looking at designing properties here in the US that we don't have. And you know, if I was in Kenya and I wanted to know what the soils were, I'd be out digging holes and making snakes with the soil and trying to figure out how much clay and how much other sand and silt was in the soil. But we have a really nice resource that all of the soils in the US are already mapped and classified, and they're all online. So this is from the Web Soil Survey. If you look up the Web Soil Survey and then type in your address, you can mark the boundaries of your property and it will fill in what all of the different types of soil types are that are on your site. And then you can go further into that. The Web Soil Survey describes what the characteristics of those soils are and what types of plants will do well on them. So here you can really get down into seeing that this area here, almost all of the soil on this site is very good soil. It's all silt loam, which is about the best type of soil for growing things. And there's a section here. This is the field on the northwest corner. It's all covered in soybeans right now. But there's these two drainage ditches that run through the middle of it. In this area, there's a number here that's 356A. So on the program, you would look up what kind of soil is that, and that's a silty clay. So it's a heavier soil that'll hold water better.
So don't soils change, or is there some essential characteristics that are in that?
The texture of soil is not going to change very much over our lifetime. It's going to change over really long periods of time, you know, glacial periods of time. But there are things you can do on a small scale to manipulate the soil. Adding organic matter is pretty much the biggest one, but also some other nutrients and like compost teas and things to activate more of the biology in the soil. But the texture, the size of the particles in the soil, you're pretty much stuck with what you've got. So this will help you when you start to look at, okay, I've got this whole property now. Are there certain areas that I want to focus on? Or are there certain areas I want to stay away from? If I'm trying to plant this type of plant that I know survives in this climate, where would be the best soil on the property? Because putting a plant in the best soil is going to be one of the best ways you can make that plant happy and have it grow real well for you. This is a little more blurry, but this is a 10-foot, or I think it's about a 10-foot contour map of the property here. I just pulled this off of a site. I think you can get better topo maps than this, but this is from a site called mytopo.com. You can preview maps there. It works better on larger scales. It's not very good for fine scale like urban lots, but you can get topo maps as well from different sources. But this shows you here how this is the drainage area coming down through here. So the property is gradually falling from the northwest corner into this field, but then it comes up again to the top of the mound here where we're sitting. So this can give you an idea also of slope and contours. So those are other features, patterns on the landscape that you're gonna wanna be looking at.
How do fruit trees compare between like a sandy loam and a silty loam? What is the more ideal for like pears and apples? Is there a particular type of soil that you like more?
It varies between different types of
Okay.
fruit trees. Cherries, like stone fruits, tend to like better drained soils, so something a
Okay.
little more sandy where, pome fruits like apples and pears and things like a little bit heavier soil.
Okay.
And so berries and things kind of vary depending on
Okay.
the type. So this is another thing, contouring. Before I get into a couple other methods, I wanna back up for a minute and talk about kind of the steps of what you're trying to achieve in the design process. And so what we want, to achieve is the desired conditions. Let's just call them the desired conditions. And the desired conditions are things that will make sure that our system is functioning well. So this includes like maximum ecosystem health. So you have good diversity, you have good fertility, you have healthy plants, you have a functioning ecosystem. That's important, so things are working well, but you also want to have high yields, high and diverse yields. Of the as many of the 6 main functions as you can from your system. And then you want your system to be as self-maintaining as possible. So these you could think of as our goals that we're working towards. That's like our big picture. If we could achieve a system that can do these things, we're going to really be happy. But to get there, they're kind of abstract. So you need to have a functioning ecosystem. So this gets back to kind of ecosystem health. Like, what are the dynamics in our ecosystem that we want to have happen? And I'm just going to list out a lot of these, but I don't think we're going to have time to go into them really in depth. But this includes like self-renewing fertility. So not having to add nutrients or compost or fertilizer to your system to keep it healthy. That it creates, you have enough diversity, you have different types of plants in your system, and organic matter, and mulch and things. You have plants that are actually producing those things in your system. So you're growing your own mulch. You have nitrogen fixing plants that are fertilizing the soil for you. They're taking nitrogen out of the air and putting it into the soil. And you have another type of plants that are called accumulators or dynamic accumulators. And these are plants that have really deep tap roots and really leafy vegetation. So one of the classic ones is comfrey. That has a nice deep taproot that has really big leaves, and so it's a perennial, but a couple times a year it will grow out these really big leaves, and then you can either cut them or the leaves will naturally fall off and then regrow. And so they pull up, they're pumping nutrients up out of the soil from deep down in the soil, and then they're depositing their leaves up on the surface of the soil, so making those nutrients accessible to all the other plants that are growing and accessing, they're feeding in the shallow layer in the soil.
If you have like a hill and you have something like, you plant like a black walnut on top, that has a deep taproot, would that hypothetically pull up the capillary movement of the water up for other plants, or is that kind of like not big enough to really do that.
Yeah, trees are great water pumps. That's one of the big functions that trees do, yeah. And they transpire and
Yeah.
create a more humid environment around them.
Would be ideal. Bigger tap roots at the top of the hill as you move down through the properties.
Yeah. Okay, so we're self-fertility, minimal competition. So you want to have high diversity but low competition. So this gets back to, we don't just want to have dozens of types of plants just for the sake of having diversity. We want to have plants that complement each other, that really work well together. So it's not a random assembly of plants. It's plants that are connected, have high connectivity, and benefit each other. So this has to do with plant selection and placement. So when you're putting, black walnut's a great example. Black walnuts and butternuts, they have chemicals that they release that lots of other vegetables and trees don't grow well next to. So apples are a good example. Apple trees and walnuts don't grow well together. If you have a walnut tree that's already established and you plant an apple tree under it, it's not going to grow very well, it's not going to fruit. But there are other trees that do well with apples and do well with walnuts. And an example of that is a mulberry. And there are lots of native mulberries around here. So if you planted an orchard that had a black walnut and a mulberry and then an apple in between it, they'd all be happy. And you'd have more diversity. Another one is sustainable water. Demand. So this is, has to do with planning out how many plants or the spacing of plants and the type of plants based on how much water your site is going to collect, how much water is available on your site. So you're not overplanting your site where it's going to need irrigation. So if you want self-maintenance, you're going to have to make sure that your water demand isn't too high. So that's kind of like limiting your design a little bit, but also gets you to think about what else you can do to store water in your soil, like swales and mulching. So those are some of the things. Along with competition, I would say minimizing herbivory and disease. So these go along with healthy plants. And that's going to be another thing that's has a lot to do with diversity, but also has to do with the relative location of things, putting things in places where if you're going to plant an apple tree, you could plant things around the apple tree that things like deer and mice won't eat or won't like. So examples are if you're planting an apple guild where you have an apple tree in the middle, a lot of people suggest for the first 2 feet putting gravel around, like pea gravel around the base of the tree, because rodents and things like mice and voles that like to girdle trees or chew on them won't enjoy having gravel around there because they can't dig through it very easily. But then planting a number of leafy plants around here, like horseradish or daffodils, flowers, things like that deer will not eat. So you're minimizing the attractiveness of this situation to rodents and deer, which would be your 2 biggest herbivores that would want to eat your apple trees.
What does that say, minimize
Herbivory, like insects and animals that are going to eat your trees or plants. So these are kind of the ecosystem dynamics, the things that you want to create or you want to have happening to achieve these conditions. And so the way to do that And now we're gonna get into the more exciting examples of how to do design stuff, but it's kind of a three-step process, that's the way I see it, is, so looking at the four elements of design. Or kind of the four pieces that have to fit together that make up a good design that has the best chance of achieving these things. So this is the existing conditions. And those are the things that we've been talking about that include the climate, the slope of the land, water, the soil, all of the vegetation, the animals, all of the things on the site that you're going to want to get out and look at. And an example of that, of how to assess the existing conditions, is what's called sector analysis. So sector analysis generally are looking at energies that are coming from outside the site. So energies that are entering the site that you don't really have the ability, for the most part, to control, but they're things that you have to take into account to make a good design. And so usually the way that sectors are, the easy way to represent them is to start in the center of your design when we were talking about where your house is or your locus of activity is, and then drawing out these wedges or these pieces, like where different energies are coming from. So some examples of energies are your coldest wind or your predominant wind direction. In this case, I think the dominant wind is probably coming from the northwest. So it'll make you think about, okay, if we have a real strong wind sector coming from the northwest side, we're going to want to establish as much windbreak on this side as possible before we plant any of our fruit trees or vegetable gardens or animal pastures or anything like that on the downwind side of it, because all of those things are going to be healthier, less stressed if they're not being, don't have this predominant wind blowing on them. Other examples besides the wind include like corridors from animals. If you think about like if you have a forest preserve next to your property, or some other place where animals. If you have a great area where predator birds like owls or hawks like to stay, you want to take that into account where their main activity patterns are on your site, so you can take advantage of that, or you can minimize conflict with your design. Soils, I also consider soils to be a good thing to mark out. They don't usually work out in nice sectors like that, like triangles or something, but you want to lay those things out on your base map before you start looking at where you're going to place things. So does everybody kind of understand the idea behind sectors? That you're assessing these things that exist on your site ahead of time? Okay. So then the next part is the desired components. This gets back to the functions that we're trying to create: the food, shelter, water, energy, waste, and community. So these are the desired components. And a good way to think about this is through zones. As far as where do I want these things, we talked about thinking of elements and thinking about how many times do I need them, how often do I need them, or how frequently do they need my visitation of them. So you can use the zones and sectors together if you decide, okay, I want to have an herb garden, but so that's going to be in zone 1. So where in zone 1 would I place it? You have all of these options, assuming that you could put it anywhere on any side of zone 1. So then your sectors, you look at your soil, your existing vegetation, other potential benefits or threats, and that'll tell you whether to put it on this side or on this side, over here, where the best location for that desired component will be. So that's the combination of zones and sectors that help you figure out the relative location. And the third part is patterning. This goes along with assessing the existing conditions, which the existing conditions is kind of looking at sectors, which we can also think about patterns that exist on the site. But this part is patterns that you're going to overlay onto the site, things that you're going to create. And this includes things like creating swales or planting a guild, companion planting, cover cropping, things that you might do to prepare the soil before you plant. You know, when we planted our orchard, our food forest at our family's farm, first we had a cornfield, and so we went through 3 different cover crops before we made our swales. It was originally a cornfield, so we chopped all that down and we added fish emulsion and beneficial bacteria. We sprayed that on to the residue, the crop, the corn stubble and things like that. We plowed it in and we planted peas and oats over the top of it as an early spring crop. So that grew up really fast. Then we cut that down. We plowed that into the soil because we added nitrogen, we added organic matter. Then we planted buckwheat, which was a great smother crop. It's a really dense summer crop. And we let that grow up until it was flowering. And then we also cut that down and plowed that into the soil to add a ton of organic matter because the soil was really heavy and it didn't have a lot of organic matter into it. So this was our way of like growing our own compost and incorporating it into the soil. So then after we plowed in the buckwheat, then we finally planted our final cover crop, our ground cover, which was this mixture of clover, different types of clover, and vegetables for the deer, the sugar beets and turnips and kale. So that was kind of the successional process. And at that point we thought, okay, our soil is improved enough now that we're going to make our swales, and then we're going to plant our fruit trees. So it's this process of deciding what to do before planting the fruit trees. And I think a good way of thinking about this is through element analysis. And these are all things that deserve more time and deserve more thought, and I apologize for not having enough time to take you through full examples of all these, but element analysis is what we were talking about before. It helps you with zones as well, but it tells you what your site might be missing or the best way to put something onto your site. So the way I think about it is through what are your needs. So let's think about, for a minute, let's think about a chicken. I'm going to draw my best chicken here. So here's my chicken. So what are all the needs of a chicken? What does a chicken need? What are some things that a chicken needs? Oxygen. Is it okay to just put air? Air is sufficient?
Feed.
Feed, okay. Which could include lots of different things. It could include plants, insects, grains, waste vegetables, things like that. Okay, what else does it need?
Water.
Water? What were you saying? A place
To poop.
Oh, a place to poop. Okay. Poop places.
Space to move out. Do chicken things.
Space, okay, space.
Chicken.